Hello, my dear friends. Elrigu namaskara. Myself 𝐁𝐚𝐿 ನಿಮ್ಮ chemistry faculty. I welcome back you all to this incredible platform physics wala. ಈಗ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಏನ್ ನೋಡಿದೀವಿ? ಲೆಕ್ಚರ್ ನಂಬರ್ 3 of the preparations of alkynes and the physical property and its chemical property ನೋಡಿದೀವಲ್ವಾ? Now this lecture number 4 is very important. ಯಾಕಂದ್ರೆ here we are going to see the aromatic hydrocarbons. ಅದರಲ್ಲಿ aromatic hydrocarbons we are going to see its chemical property, that is electrophilic substitution reaction. This electrophilic substitution reaction in the we can expect one or two questions. ಈಗ this electrophilic substitution reaction basics na entire chemistry we will use. ಈಗ in the entire chemistry ಅಲ್ಲಿ this aromatic electrophilic substitution reactions, nitration, sulfation, phenyl cap, alkylation, acylation, halogenation, ಇದರೆಲ್ಲಾನು we are this basics that all we are going to see in this lecture. Don't see the lecture in the 2x. Now ಈಗ these basics are very important. We can expect one question in every entrance exam, in any entrance. If you are preparing for the JEE, if you are preparing for the Neet, if you are preparing for the KCET or any other exam, without question from this topic there is no exam. Or else ಈಗ ಈ question ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ maybe they may ask the question based on this concept. They will interlink this concept in the middle of the question. Clear? Now this concept is very important. Now aromatic hydrocarbon chapter is very important. You can note. Now let's start our chapter. Topics to be covered. Idralli we are going to see the aromatic hydrocarbons. Now aromatic hydrocarbons andre ಏನು ಅಂತ we are going to see. Next its physical properties. ಮತ್ತೆ next chemical properties. Clear? Now these all are we are going to cover in this lecture. Okay? Now aromatic hydrocarbons. ಈಗ aromatic hydrocarbons ಅಂದ್ರೆ ಏನು? Now benzene containing compounds are known as aromatic hydrocarbons. ಈಗ aromatic hydrocarbons we can call it as arenes. No, we can call it. Clear? ಈಗ in aromatic hydrocarbons ಅಲ್ಲಿ the compound that contain aromatic ring, in aromatic hydrocarbons ಅಲ್ಲಿ the compounds that contain benzene ring. ಈಗ benzene ring ಇದೆ ಅಂದ್ರೆ ಈಗ ಆ compounds ಗೆ benzene ring ಇದೆ ಅಂದ್ರೆ that compounds we call it as a benzenoids. ಈಗ aromatic hydrocarbons ಅಲ್ಲಿ ಈಗ compounds ಗೆ benzene ring ಇದೆ ಅಂದ್ರೆ that compounds we call it as a benzenoids. Now if there is no benzene ring, if there is no benzene ring, ಈಗ ಅದರಲ್ಲಿ benzene ring ಇಲ್ಲ ಅಂದ್ರೆ if there is no benzene ring, that we call it as non benzenoid. Okay? Now ಈಗ aromatic compounds ಅಲ್ಲಿ mainly ಈಗ aromatic compounds ಅಲ್ಲಿ the compound that contain the benzene ring that we call it as a benzenoids. ಈಗ aromatic compounds ಅಲ್ಲಿ if there is no benzene ring, that compounds we call it as a non benzenoids. Okay? Clear? Now aromatic hydrocarbon we can call it as a arenes also. Clear? Now we will see some examples of the benzenoids and some examples of the non benzenoid. Here this is benzene is the aromatic compound alwa. Benzene is a aromatic compound. ಅದಕ್ಕೋಸ್ಕರನೇ this we call it as a benzenoid. Now this is also aromatic ring is present alwa. Benzene ring is present. Here benzene ring is present andre that we call it as a benzenoids. benzenides. Now naphthalene also benzenide. Next anthracene, this is anthracene, toluene. Now biphenyl, these all are the benzenide compounds. Yakandre all containing aromatic ring and the benzene ring, all are the aromatic compounds as well as the it containing benzene ring. These are the example for the benzenides. Iga this is azulene, even though this is aromatic compound, but it is not having benzene ring. This is 7-member ring, 1 2 3 4 5 6 7. Now this is benzene, this is not the benzene, even though this is not the benzene, even though this is aromatic, this is not having the benzene ring. Adugoskarane this is not the benzenoid. This we call it as a non-benzenide. Clear? No. Next. Preparations of the benzene. Now last class alli alkynes chapters alli nodiddivu alva. ಏನು ನೋಡಿದ್ವಿ? cyclic polymerization of the ethane. ಇದರಲ್ಲಿ first if I take the acetylene, cyclic polymerization of the acetylene. Now in the Fe iron tube, Fe in the presence of iron tube at the high temperature. Now ಏನಾಗುತ್ತೆ acetylene, now it will give the benzene alva, it will give the benzene like this. Now this is the preparation of the benzene. Iron Fe in the red hot tube, Fe in the red hot tube. Iron in the red hot tube at high temperature. When the acetylene it is present, then acetylene gas when it is present, then it will be converted into the benzene, Clear? Now by the cyclic polymerization of ethane we can prepare the benzene. Clear? Now second preparation. Now ಈ reaction ಎಲ್ಲಿ ನೋಡಿದ್ವಿ? This reaction we have seen in the preparation of the alkanes alva. Preparations of the alkanes. Now decarboxylation reaction. Now soda lime decarboxylation reaction in the this group entire it will be eliminated and hydrogen will be added alva. Now this is illindanu we can prepare the benzene. Decarboxylation reaction. ಈಗ ಈ reaction ಎಲ್ಲಿ ನೋಡಿದ್ವಿ? We have seen in the alkanes chapter alva. We can see in the alkane chapter. ಈಗ ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆ ಅಂದ್ರೆ you can go and see that alkane chapter, preparation of the alkanes, lecture number 1 ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. Clear? Next. Phenol in the presence of zinc dust. ಈಗ phenol in the presence of the zinc dust ಈಗ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು, it will remove the OH and it will give the benzene. And it will form the zinc oxide. Clear? Now these are the three preparations. Now zinc dust, phenol in the presence of the zinc dust, directly it will give the benzene. Okay. Next, physical properties of the aromatic hydrocarbons are the non-polar. Most of the non-polar compounds, benzene is a non-polar compound alva. Adugoskarane benzene it will not dissolve in the water. Aromatic hydrocarbons are non-polar. Now alkanes also non-polar. Alkanes also non-polar. Alkanes also it will not soluble in the water. Aromatic hydrocarbons are also non-polar, but alkenes and the alkynes are polar due to the presence of pi bond. It will show the polarity. Alkenes and the alkanes are the polar, alkanes and the aromatic hydrocarbons are the non-polars. Okay, these usually colorless liquids are solids. Now aromatic hydrocarbons are insoluble in water. Yakandre water is the polar alva. Now like will dissolve in the like will dissolve in the like, unlike will dissolve in the unlike. Okay, now alkanes will dissolve in the benzene, alkanes will be dissolved in the benzene. Clear? But these aromatic hydrocarbons will not be dissolved in the water. Yakandre water is the polar and the aromatic hydrocarbons are the non-polar. Clear? Now, but soluble in the organic solvents like alcohols and the ether. Now, these aromatic hydrocarbons will soluble in the organic solvents. Okay? Organic solvents, even though these are the polar, organic solvents under this is ether. Ether is a ether. It is ether and the alcohols. Okay? Next. Electrophilic substitution reaction. This is very important. This is very important, and repeatedly we can expect in any entrance exam we can expect one question from this topic. This topic in the we can expect one question. Now this question if they have not asked any question from this concept, they will ask from this content. E content in the they may ask in the middle of the reaction they may ask. This is very important. Electrophilic substitution reaction is very important. Now substitution reaction andre enandre, substitution reaction means by replacing of the one electrophile in the one electrophile is replaced and the another electrophile is added, that we call it as a aromatic electrophilic substitution reaction. One electrophile is replaced and the one electrophile is added andre, not that clearly ನಾನು explain ಮಾಡ್ತೀನಿ. ಈಗ upcoming slides ಅಲ್ಲಿ ನಾನು clearly explain ಮಾಡ್ತೀನಿ. ಈಗ just you listen. Now this electrophilic substitution reactions is shown by the benzene as well as the homologous andre, now benzene and its compounds phenol, toluene, these all contain phenol. It is having the aromatic ring alva, aromatic ring. Now this is having the aromatic, this is a phenol. Now toluene is also having the aromatic ring. Clear? Now etc. undergoes this aromatic electrophilic substitution reaction. Aromatic ring irbeku. Electrophilic substitution, aromatic electrophilic substitution reaction to show there should be a aromatic ring. Now this is having aromatic ring, that is also having the aromatic ring alva. Now this is non-concerted reaction. This is non-concerted reaction andre intermediate is present. Now ಈಗ ಎಲ್ಲ ಇದರಲ್ಲಿ electrophilic substitution reactions ಅಲ್ಲಿ aromatic electrophilic substitution reaction ಅಲ್ಲಿ we are going to see the nitration ಅಲ್ಲಿ we are going to see the NO2, nitronium ion is a electrophile. Now halogenation ಅದರಲ್ಲಿ Cl plus, ಈಗ ಕ್ಲೋರಿನ್ ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ Cl plus is the electrophile. ಈಗ ಸಲ್ಫೋನೇಷನ್ ಅಲ್ಲಿ ಸಲ್ಫರ್ ಟ್ರೈಆಕ್ಸೈಡ್ is a neutral electrophile. Clear? Now Friedel-Crafts alkylation ಅಲ್ಲಿ R plus or alkyl CH3 plus. ಈಗ CH3 methyl chloride ತಗೊಂಡಿದ್ದೀರೋ ಅಂದ್ರೆ CH3 methyl cation is a electrophile. Clear? That ಎಲ್ಲಾನು we are going to see. ಅದಕ್ಕೋಸ್ಕರನೇ this is non concerted reaction. Concerted ಅಂದ್ರೆ there is no any intermediate present. Non concerted ಅಂದ್ರೆ intermediate will be present. This is a electrophilic substitution reaction. Next, this reaction, electrophilic substitution reaction, takes place with the 3 steps. ಎಲ್ಲಾನು ಈಗ nitration alkylation, Friedel-Crafts alkylation, acylation, halogenation, sulfonation. These 5 reactions what we are going to see in the electrophilic substitution reaction will follow these 3 steps only. All the 5 reaction what we are going to study, that all will follow only these 3 steps. Only this. First step ಏನಂದ್ರೆ formation of the electrophile. Next, formation of the sigma complex. Now this sigma complex is the intermediate. This is the intermediate. Now last step, elimination of the electrophile. Now aromatic electrophilic substitution reaction alli now first formation of the electrophile alwa, first formation of the electrophile. ಈಗ this electrophile first we have formed the electrophile. Next electrophile we have added to the benzene. Now this is deep on delocalization will be happened. Now this we call it as a sigma complex, and the last this proton will be eliminated. Andre one electrophile added, one electrophile has been eliminated. One electrophile added, one electrophile has been eliminated. That's the reason we are saying it as a substitution. Substitution andre replacement. One electrophile should be one electrophile has been substituted, another electrophile has been eliminated. Adigoskara we are saying electrophilic substitution reaction. Addition reaction andre ಏನು? Addition reaction andre ಏನು? Addition reaction means that electro or nucleophile should combine attack. Nucleophilic addition reaction, electrophilic substitution reaction, nucleophilic addition reaction, electrophilic substitution reaction. Clear? Now, ಈಗ these three steps it will be followed. First step is the formation of the electrophile. Now this is E nucleophile alwa. Now idralli let's take just for your example, now here I am giving, now here that is one electrophilic and there is one nucleophilic alwa. Now electrophiles are more electronegative. It will take here the Cl and the Cl if it is there, Cl, and if it is Cl it is there. Now here any, or else let's take, this is one electrophile, one is nucleophile. Now sir electrophile nucleophile ante ಏನಂದ್ರೆ ನಿಮಗೆ ಅಪ್ಕಮಿಂಗ್ ಸ್ಲೈಡ್ಸ್ ಅಲ್ಲಿ ನಿಮಗೆ ಎಲ್ಲಾನು ಅರ್ಥ ಆಗುತ್ತೆ, ಬಟ್ ಈಗ ನಾನು ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೇನೆ ಅಂದ್ರೆ ನಿಮಗೆ ಏನು ಅರ್ಥ ಆಗಲ್ಲ, ಬಟ್ ಕ್ಲಿಯರ್ಲಿ ನಿಮಗೆ ಅಪ್ಕಮಿಂಗ್ ಸ್ಲೈಡ್ಸ್ ಅಲ್ಲಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಫೈಲ್ ಅಲ್ವಾ, ಫಸ್ಟ್ ಸ್ಟೆಪ್ formation of the electrophile. Now formation of the electrophile andre E place andre electrophile, don't get confused, E place andre electrophile. Nucleophile it will take the bond pair of electrons. Now nucleophile it will be idralli H2O ಇದೆ ಅಂದ್ರೆ now it will be dissociate to the H plus and the OH minus alwa. Now this is nucleophile. Now H plus here it is the electrophile. Clear? In the same way aromatic electrophilic substitution reaction alli first we have to generate the electrophile. Next that electrophile should be attacked to the which benzene, that it should be attacked to the benzene. Now how it will be attacked to the benzene andre benzene alli 3 pi bonds irutalva. Now one pi bond has been delocalized to this carbon. Now ಈಗ when this pi bond has been delocalized to this carbon, now ಈಗ ಈ carbon ಮೇಲೆ ಏನು ಬರುತ್ತೆ ಚಾರ್ಜ್, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ವಾ, negative charge. Now negative charge, now this electrophile will combine attack towards this carbon. Now when the electrophile has been attacked towards this carbon, this carbon has been lost its electron alwa. Now this carbon will get the positive charge. Now to stabilize this positive charge, this pi bond will be delocalized here. Now this is the delocalization symbol. Now delocalized here. Clear? This pi bond when it has delocalized here, ee carbon ge idralli positive charge barutalva. Next again this pi bond will be delocalized here. When this pi bond has been delocalized here, ಈಗ ಈ carbon ಗೆ ಇದರಲ್ಲಿ positive charge ಬರುತ್ತಲ್ವಾ. Now keep on this chain, it is keep on proceeding, delocalization. Benzene it will show the delocalization alwa. Benzene it will show the delocalization alwa, like this. Benzene it will show the delocalization. Keep on ring delocalization, it will happen. That's the reason this is the intermediate that we call it as a sigma complex. Now benzene ಅಲ್ಲಿ ಇದರಲ್ಲಿ ಒಂದು ಹೈಡ್ರೋಜನ್ ಇರುತ್ತೆ, 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 ಇದರಲ್ಲಿ ಒಂದು ಹೈಡ್ರೋಜನ್ ಇರುತ್ತಲ್ವಾ. ಕ್ಲಿಯರ್? ನೌ ದಿಸ್ ಈಸ್ ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಸಿಗ್ಮಾ ಕಾಂಪ್ಲೆಕ್ಸ್, ದಟ್ ಈಸ್ ದ ಇಂಟರ್ಮೀಡಿಯೇಟ್. ಸಿಗ್ಮಾ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇಸ್ ದ intermediate. Next elimination of the H plus alwa, elimination of the H plus. Now elimination of the H plus after the delocalization, now this carbon has been positive charge alwa, again this sigma bond of this hydrogen it will give this sigma bond to the ring, and the next aromaticity is stored. Now this hydrogen has went with the positive charge alwa, now electrophile and the nucleophile, now when it has reached electrophile is a positive charge, nucleophile is a negative charge alwa. Now this proton this proton will be attacked to the whatever the nucleophile we have generated here, the proton which is eliminated, that will go and attack to the nucleophile, clear? Now this is the basic steps, for each and every reaction. Because whatever the reaction we are going to study in the electrophilic substitution reaction, these steps only it will follow. Now these points are very, very important. This Iga, if you remember this point, you can predict the answer very fastly by seeing the question itself. First, now electron releasing groups. Electron releasing groups. If it present on the benzene ring, if it is present on the benzene ring, if it is present on electron releasing groups, if it is present on the benzene ring, it will increases the electron density, of benzene at ortho and para positions, clear? Now iga whatever the statement I wrote alwa, this statement that clearly will be explained in the next slide. Okay, now electron releasing group, iga benzene mele electron releasing groups andre ಏನು ಅಂದ್ರೆ, this to understand electron releasing groups ಮತ್ತೆ electron withdrawing groups, to understand you have to study the GOC lecture. ಈಗ ಇದರಲ್ಲಿ GOC lecture ಅಲ್ಲಿ you will get to know what is the electron releasing groups. Now the one which donate the electrons, that we call it as the electron releasing groups. Now next point. Now electron withdrawing groups. ಈಗ electron withdrawing groups present ಅಂದ್ರೆ benzene ಮೇಲೆ electron withdrawing groups. ಈಗ benzene ಮೇಲೆ electron withdrawing groups ಇದೆ ಅಂದ್ರೆ, electron withdrawing groups, if it is present on the benzene ring, if it is present on the benzene ring, it will decrease as the electron density of benzene at ortho and para positions. Clear ಆಯ್ತಲ್ವಾ? ಈಗ electron withdrawing groups benzene ಮೇಲೆ electron releasing groups ಇದೆ ಅಂದ್ರೆ, electron releasing groups ಇದೆ ಅಂದ್ರೆ, it will increase the electron density at ortho position. ಇದನ್ನ ortho position ಅಲ್ವಾ? Now this is para position. Clear? Now this is the meta. ಅಂದ್ರೆ electron release groups ಅಂದ್ರೆ, electron releasing groups ಇದೆ ಅಂದ್ರೆ, it will increase the electron density at the ortho as well as the para. Okay? Now ಈಗ if electron withdrawing groups ಇದೆ ಅಂದ್ರೆ, it will increase the electron density at the meta and it will decrease the electron density at ortho and the para. ಇದರಲ್ಲಿ ಎರಡಲ್ಲಿ ಆರ್ಥೋ ಪೊಸಿಷನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಇದೆ ಅಂದ್ರೆ, ಆರ್ಥೋ ಪೊಸಿಷನ್ಸ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ, ಪ್ಯಾರಾ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ. ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಜಾಸ್ತಿ ಇದೆ ಅಲ್ವಾ, ಅದಕ್ಕೋಸ್ಕರನೇ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಇಸ್ ಇನ್ಕ್ರೀಸ್. ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ ಇದೆ ಅಂದ್ರೆ ನಾವು ಆರ್ಥೋ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ, ಪ್ಯಾರಾ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಪ್ಯಾರಾ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ, ಆರ್ಥೋ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಸರ್ ಹೌ? ನೌ ದಟ್ ಆಲ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ನೌ. ಓಕೆ, ನೋಡಿ. electron releasing groups are also called as a ring activating groups. Now idna, if you remember these groups, you can predict the answer very, very fastly. Clear? Electron releasing groups are also called as a ring activating groups. Electron releasing groups are also called as a ring activating groups. ಈಗ ಬೆಂಜಿನ್ ಮೇಲೆ if these groups are present, ಬೆಂಜಿನ್ ಮೇಲೆ ಈಗ if these groups are present, now ಅದು ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಬೆಂಜಿನ್ ಮೇಲೆ it will increase the electron density at ortho and para position. Now these electron releasing groups are called as a ring activating groups alva. Now ring activating groups are of the three types. One strong ring activating groups which will activate the ring very fastly, andre which will increase the electron density at the ortho end position. Ika ee ella groups benzene mele idi andre it will increase the electron density at the ortho and para positions alva. Adrallinu competition, the one which readily increase the electron density at ortho and position. Next averagely, next very slowly it will be increased. Clear? Now adralli first yavadu, first see when it comes to now NH2, first is NH2, H minus, next O minus, next NH2. When it compared to the NH2 and the OH, NH2 will readily release them. Iga which one will strongly ring activate, which one will activate the ring very fastly? NH2 matte phenol and the aniline and the phenol, which one will activate the ring very fastly andre aniline will activate the ring very fastly. Yakandre oxygen matte nitrogen alli nitrogen is a less electronegative andre it will release the lone pair of electrons very fastly. Oxygen is a more electronegative, oxygen iga ಜಾಸ್ತಿ electronegative alva, adugoskaraನೆ it will hold the lone pair of electrons very fastly. Adugoskaraನೆ when compared to the NH2, when compared to the OH, NH2 will increase the electron density at the ortho position and the para position very fastly when compared to the OH. Clear? Now these are the orders. OH3 ಮತ್ತೆ methoxy ಅಲ್ಲಿ OH will readily increase the electron density at the ortho and the para position. Now these are the groups. Now electron releasing groups, these are the electron releasing groups. Adralli we have divided into three categories alva. One is strong ring activating, one is average ring activating, one is weak ring activating. Now the strong ring activating groups alli these are the groups. Now average ring activating alli these are the groups we are having. Now this is allyl and the alkali are the weak ring activating groups. Now iga nodona how these groups will increase the electron density at the ortho and para position. Now first I am taking the phenol. Nan phenol tagondidini andre this is the phenol alva. Onde ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು ನಾನು sir, how to identify the electron releasing groups and how to identify the electron withdrawing groups. How to identify the electron releasing groups and how to identify the electron withdrawing groups are the strong. Now electron releasing groups how to identify andre benzene, idralli benzene alva, this is benzene carbon attached atom, this benzene carbon alva, this is benzene carbon attached atom or compound or anything. If it is having lone pair of electrons, that we call it as a plus M effect, that it is called as a plus M groups or electron releasing groups. Clear? Now benzene attached, most of the time how to identify the plus M groups, this we call it as a plus M groups or the electron ring activating groups. How to identify the ring activating groups andre benzene attached carbon atom, if it is having the lone pair of electrons, iga lone pair of electrons idi andre that it will comes under the ring activating groups. Some are sir, iga you may get a doubt, sir idralli now alkali now this alkali alli it is not having lone pair of electrons alva, it is not having lone pair of electrons alva. Now how it has came the ring activating group, that it will be activate the ring by non bonding resonating structure, that I will show you. Clear? Now this is first how it will increase the electron density at the ortho and para position. Now no. Now this lone pair of electrons will be delocalized here. Now this pi bond will be shifted here. Okay. Now oxygen ಮೇಲೆ put the positive. Now this is H. Now ಇದರಲ್ಲಿ negative charge alva. Clear? Next. Now again this negative charge will be delocalized here. Now this pi bond will be delocalized to here. Now here it will get the negative charge, here it is positive, here it is positive. Oh, clear? Now next, again this negative charge will be delocalized here and this will be delocalized to here. Now here it is negative charge, here it is having the positive, now here it is having the positive. Clear? Now here the bond. Clear? Next, again this will be delocalized here, again it will be delocalized here. Again it will be delocalized here. Again it will be delocalized here. Sorry. So bond is here. Now again it will be delocalized here. Now this pi bond again it will be shifted towards oxygen. Clear? Now again aromaticity stored. Iga illi nodi. Now when these ring activating groups are present, it is increased the electron density at ortho position, at para position and ortho position salva. Ortho position, it has been increased the electron releasing groups idi andre, it is increasing the electron density on the benzene at ortho and para position salva. Ortho, para, ortho. It has been increased the electron density at the ortho and para positions alva. Now ಈಗ next it has been increased the electron density at the ortho and para position alva. Now by this benzene attached carbon, if it is having lone pair of electron, that will comes under the plus same groups or electron releasing groups. If there is no any lone pair of electrons, if this type of CH3 alkali, if it is attached, how it will increase the electron density, now this it will show the non-bonding resonating structure. Alkali it will show the non-bonding resonating structure andre. Now here this is having the 3 alpha hydrogens. These 3 alpha hydrogens will show the non-bonding resonating structure. These 3 alpha hydrogens will show the non-bonding resonating structure. Non-bonding resonating structure andre hyperconjugation. Non-bonding resonating structures. This will give the non-bonding resonating structures. Here this carbon, it is having the 3 hydrogens alva, like this. 3 alpha hydrogens it is having. Get these 3 alpha hydrogens, idರಲ್ಲಿ these 3 alpha hydrogens. Now this bond will be delocalized and this pi bond will be delocalized like this. Here the carbon, see, full bond, the double bond. Now idರಲ್ಲಿ H. Now this is a negative charge. Clear? Now this again, this pi bond will be delocalized. Now negative charge will be delocalized here and this pi bond will be delocalized to here. Now negative charge, positive, positive. Now double bond, C, H, H. Now this we call it as a non-bonding resonating structure. Again, this negative charge will be delocalized and this pi bond will be delocalized here. Now here the negative charge. Clear? Now again it will be restored. Again the aromaticity will be restored. Again the aromaticity will be restored. Clear? Now idralli nodi same. When this alkali is also present, it will increasing the electron density at the ortho and the para position. It will increase the electron density at the ortho and para position. This we call it as a non-bonding resonating structure. This we call it as a non-bonding resonating structure. Clear? Now this is a weak ring deactivating group. Now due to the presence of lone pair of electrons, it will strongly activate the electron density at the ortho and the para positions. Ortho and the para position. Clear? No. Next. Iga benzene mele, if the electron withdrawing groups are called, that we call it as a ring deactivating groups. Iga ring deactivating groups, electron withdrawing groups idi andre benzene mele electron withdrawing groups idi andre ಏನು ಮಾಡುತ್ತೆ ಅದು, it will deactivate the electron density on the benzene alwa. It will deactivate the electron density at the ortho and para position. The ortho and para position alli electron density deactivate agutalwa. Now when the electron releasing idi andre at ortho and para position electron density increasing andre it is getting minus charge alwa. Minus charge andre electron it is having electron density, it is increasing at the ortho and para position. When electron releasing groups idi andre, ಈಗ electron withdrawing groups idi andre it will deactivate the ring at the ortho and para position. Now this you have to remember. Now which one will deactivate the ring, which groups will deactivate the ring? This ಈಗ benzene ಮೇಲೆ nitro group, NH3 ammonium ion, ಈಗ ಈ ತರ groups ಇದೆ ಅಂದ್ರೆ it will strongly deactivate the ring, group. Clear? Now this is weak ring deactivation group. Sir ಈಗ ಇಲ್ಲಿ ನೋಡಿ ಸರ್, ಯು ಆರ್ ಸೇಯಿಂಗ್ ಈಗ ಬೆಂಜಿನ್ ಮೇಲೆ ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ಡ್ ಗ್ರೂಪ್ಸ್, ಈಗ ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ಡ್ ಗ್ರೂಪ್ಸ್ ಗೆ ಏನಾದ್ರು ಲೋನ್ ಪೇರ್ಸ್ ಇದೆ ಅಂದ್ರೆ, ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ಡ್ ಗ್ರೂಪ್ಸ್ ಆರ್ ಆಟಮ್ ಗೆ ಲೋನ್ ಪೇರ್ ಇದೆ ಅಂದ್ರೆ, ಸರ್ ಯು ಸೇಡ್ ದಟ್ ಇಟ್ ವಿಲ್ ಆಕ್ಟಿವೇಟ್ ದ ರಿಂಗ್ ಅಲ್ವಾ? ಎಸ್, even though these are the weak ring deactivating group, it will increase, these groups will increase the electron density at the ortho and para position. Even though this will comes under the weak ring deactivating group, even though this category of this is weak ring deactivating groups, these groups will increase. ಈಗ ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು, this is very very important. This group will increase, electron density. These groups increase electron density at ortho and para positions, even though this category is weak ring deactivating group, it will increase the electron density at the ortho and para position. ಕ್ಲಿಯರ್ ಆಗಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಲ್ವಾ? ದಿಸ್ ಬೆಂಜಿನ್ ಅಟ್ಯಾಚ್ಡ್ ಕಾರ್ಬನ್, ಈಗ ಬೆಂಜಿನ್ ಕಾರ್ಬನ್ಗೆ ಅಟ್ಯಾಚ್ಡ್ ಆಟಮ್ಗೆ ಏನಾದ್ರು ಲೋನ್ ಪೇರ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಅಟ್ ದ ಆರ್ಥೋ ಅಂಡ್ ದ ಪ್ಯಾರಾ ಪೊಸಿಷನ್ಸ್. ಕ್ಲೋರಿನ್ ಆಲೋಜನ್ಗೆ 3 ಲೋನ್ ಪೇರ್ಸ್ ಇದೆಯಲ್ವಾ? ಈವೆನ್ ದೋ ಇಟ್ ವಿಲ್ ಕಮ್ಸ್ ಅಂಡರ್ ದ ರಿಂಗ್ ಡಿಆಕ್ಟಿವೇಟಿಂಗ್ ಗ್ರೂಪ್, ಈಗ ಇಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಅಟ್ ದ ಆರ್ಥೋ ಅಂಡ್ ಪ್ಯಾರಾ ಪೊಸಿಷನ್. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನಾವು average ring deactivating group. Now iga aldehyde, ketone, acid halide, amide, now esters, now benzoic acid or sulfonic acid, iga ellano idi andre this all will deactivate the ring. Now ಈಗ ನೋಡೋಣ how it will deactivate the ring ಅಂತ. ಇದರಲ್ಲಿ ಫಸ್ಟ್ clear. If I take a benzaldehyde, okay, if I take a benzaldehyde, ಇಲ್ಲಿ ನೋಡಿ this is benzene carbon ಅಲ್ವಾ, ಬೆಂಜಿನ್ ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ಡ್ ಆಟಮ್ ಗೆ ಏನಾದ್ರೂ ಲೋನ್ ಪೇರ್ಸ್ ಇದೆಯಾ, ಕಾರ್ಬನ್ ಗೆ ಏನಾದ್ರೂ ಲೋನ್ ಪೇರ್ಸ್ ಇದೆಯಾ, ಕಾರ್ಬನ್ ವ್ಯಾಲೆನ್ಸಿ is 4, it can form the 4 bonds. There is no lone pair on the carbon, that's the reason it will ring deactivating group. Now by that you can identify which group is a ring activating group, which is a ring deactivating group. ಈಗ ಕಾರ್ಬನ್ ಮೇಲೆ ಏನು ಲೋನ್ ಪೇರ್ಸ್ ಇದೆಯಲ್ವಾ, ಅದಕ್ಕೋಸ್ಕರನೇ this will act as a ring deactivating group. ಈಗ ಲೋನ್ ಪೇರ್ ಇದೆಯಾ ಅಂದ್ರೆ that is ring activating group. Clear. Now carbon ಮತ್ತೆ oxygen which is more electronegative, oxygen is more electronegative alwa. Now this will take the bond pair of electron towards itself. Iga this oxygen has taken the bond pair of this sigma pi bond. Now this carbon ge ಏನು charge ಬರುತ್ತೆ, positive charge ಬರುತ್ತಲ್ವಾ. Now to stabilize this positive charge, now aromatic ring containing pi bond will be delocalized to this carbon. When this pi bond has been delocalized to this carbon, ಈಗ ಈ ಕಾರ್ಬನ್ ಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ವಾ. ದಿಸ್ ಇಸ್ ಕಾರ್ಬನ್ O minus and this is H. Clear. Now to stabilize this positive charge, again this pi bond will be delocalized here. When this pi bond is delocalized here, now here this carbon will get the positive charge alwa. Okay, again to stabilize this positive charge, now this pi bond will be delocalized to here. Now here we will get the positive charge. Idralli O minus. Really clear. Now again to stabilize this positive charge, again this this negative charge will be delocalized and this bond will be delocalized here. Clear. Now ಇಲ್ಲಿ ನೋಡಿ, here when the ring deactivating group is present, it is decreasing the electron density at the ortho and para positions alwa. Now ಇಲ್ಲಿ ನೋಡಿ, ಆರ್ಥೋ ಪೊಸಿಷನ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, ಪ್ಯಾರಾ ಪೊಸಿಷನ್ಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್, ಮತ್ತೆ ಇನ್ನೊಂದು ಆರ್ಥೋ ಪೊಸಿಷನ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಕ್ಲಿಯರ್. ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಅಂದ್ರೆ, ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಡಿಕ್ರೀಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಅಟ್ ದ ಆರ್ಥೋ ಅಂಡ್ ದ ಪ್ಯಾರಾ ಪೊಸಿಷನ್. ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಇದೆ ಅಂದ್ರೆ, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಅಟ್ ದ ಆರ್ಥೋ ಅಂಡ್ ಪ್ಯಾರಾ ಪೊಸಿಷನ್. How it will increase the electron density at the ortho and para position ನೋಡಿದ್ವಿ. ಈಗ electron withdrawing groups ಇದೆ ಅಂದ್ರೆ how it will decrease the electron density at the ortho and para position ನೋಡಿದ್ದೀವಲ್ವಾ. Clear. Now this concept is very important. Now ಈಗ when to benzene to show aromatic electrophilic substitution reaction, now these three steps it should follow alwa. Now based on that benzene ಮೇಲೆ attached group. Now ಈಗ if benzene ಮೇಲೆ one electron releasing groups ಇದೆ ಅಂದ್ರೆ, benzene ಮೇಲೆ ಒಂದು electron releasing groups ಇದೆ ಅಂದ್ರೆ, now the formation of the electrophile, this formation of the electrophile will decide where to attack this electrophile. Now benzene ಮೇಲೆ ಒಂದು electron releasing groups ಇದೆ ಅಂದ್ರೆ, now this group will decide where to attack this electrophile on the benzene, this group will be decide. Clear. Electron releasing group ಅಂದ್ರೆ it will increase the electron density at the ortho ಮತ್ತೆ para positions ಅಲ್ವಾ, ಇದರಲ್ಲಿ ಏನಾದ್ರೂ ಬಲ್ಕಿ ಗ್ರೂಪ್ ಇದೆ ಅಂದ್ರೆ, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸಿಂಗ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಏನಾದ್ರೂ ಬಲ್ಕಿ ಗ್ರೂಪ್ ಇದೆ ಅಂದ್ರೆ, now this electrophile will go and attack at the para position. Clear. Now ಇದರಲ್ಲಿ if electron withdrawing group ಇದೆಯಂದ್ರೆ electron withdrawing group ಇದೆಯಂದ್ರೆ now this electrophile will go and attack at the para position. ಯಾಕಂದ್ರೆ ಆರ್ಥೋ ಪೊಸಿಷನ್ ಮತ್ತೆ para position already positive charge. Electrophile is also positive charge ಅಲ್ವಾ. ನಾವು ಅದಕ್ಕೋಸ್ಕರನೇ ಎಲೆಕ್ಟ್ರಾನ್ ಬೆಂಜಿನ್ ಮೇಲೆ ಏನಾದರೂ ಎಲೆಕ್ಟ್ರಾನ್ withdrawing group ಇದೆಯಂದ್ರೆ electrophile will go and attack at the ಯಾವ್ದು ಪೊಸಿಷನ್ ಮೆಟಾ ಪೊಸಿಷನ್. ಅದಕ್ಕೋಸ್ಕರನೇ to identify any electrophilic substitution reaction, these groups are very important, which will activate the ring. Now if these groups are present on the benzene, where it will increase the electron density, where the electrophile should be attacked. Clear? Now if these electron withdrawing groups are present, where the electrophile should be, where it will decrease the electron density, and where the electrophile should be attacked. Clear? Now these groups are very important. ಈಗ ಇದೆಲ್ಲನೂ ನೆನಪಿಟ್ಕೋಬೇಕು. Clear? Now next ರಿಂಗ್ ಆಕ್ಟಿವೇಟಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಆರ್ಡರ್. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ these compounds, if they have given this is toluene, these groups ಈಗ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ toluene, anisole, nitrobenzene, benzaldehyde, phenol, chlorobenzene. Clear? ಇದರಲ್ಲಿ which one will activate the ring very fastly? Now this is weak ring activating group alva. CH3 is a weak ring activating group. Now OH3, this is average ring activating group. Now nitro, this is strong ring deactivating group. Now benzaldehyde, that is average ring deactivating group. Now this is phenol, this is strong ring activating group. Now this is weak ring deactivating group alva. But even though it is weak ring deactivating group, it will increase the electron density at the ortho and para position. That you have to remember. Yakandre due to the presence of this lone pair of electrons on the chlorine, it will increase the electron density at the which position? Ortho and the para position. Clear? Now arrange the order of the ring activating group. Which one will activate the ring very fastly? Now 5 will activate the ring very fastly. Next average ring activating group yavadu? Next 2. Next weak ring activating 1. Next 6 weak ring deactivating. Next average ring deactivating group. Next 4. Last is the 3. Now this is the order. Clear? Now this will increase the electron density at the ortho and the para. This will increase the electron density at the ortho and para. Clear? Now this will deactivate the electron density at the ortho and para. Now this will deactivate the electron density at the ortho and para. Now this will increase the electron density at ortho and para. Now this will also increase the electron density at the ortho and para. Clear? Now this is the ring activating group order. Clear? Now next. Now iga nodona. We'll see the electrophilic substitution reaction one by one. Now adralli the first we are going to see the nitration. Electrophilic substitution reaction alli the first we are going to see the nitration. Iga nitration alli if you see this reagent, nitric acid and the concentrated H2SO4, nitric acid and the H2SO4, if they have given, now there will get the electrophile as a nitronium ion as a electrophile. Now first, now this is benzene alva, Now electrophilic substitution reaction alli the first will follow the 3 steps. One the first generation of the electrophile, next sigma complex, next elimination of the hydrogen alva. Now first generation of the electrophile alli H2SO4 ಮತ್ತೆ HNO3, the one which readily give the H plus, that is the acid, one which readily accept the H plus, that is the base. ನಾವು ಇದರಲ್ಲಿ H2SO4 is acting as a brown state acid. H2SO4 is acting as a brown state acid. ಈಗ brown state acid ಮತ್ತೆ brown state base ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಸಿ ದ ಚಾಪ್ಟರ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಈಗ ನಾನು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಾನು ಕ್ಲಿಯರ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ಕ್ಲಿಯರ್, ಇದರಲ್ಲಿ ನಿಮ್ಗೆ ವಾಟ್ ಇಸ್ ದ ಬ್ರೌನ್ ಸ್ಟೇಟ್ ಆಸಿಡ್ ಮತ್ತೆ ಬ್ರೌನ್ ಸ್ಟೇಟ್ ಬೇಸ್ ಅಂತ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಸಿ ದ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಚಾಪ್ಟರ್. ಅಯಾನಿಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ನಾನು ಕ್ಲಿಯರ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ದ ಒನ್ ವಿಚ್ ಇದರಲ್ಲಿ ದ ಒನ್ ವಿಚ್ ರೆಡಿಲಿ ಡೊನೇಟ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆರ್ ಪ್ರೋಟಾನ್ ಇಟ್ಸ್ ನಾಟ್ ನೌ ಹಿಯರ್ H2SO4 is a strong acid alwa, ಅದಕ್ಕೋಸ್ಕರ it will readily donate the H plus, and this HNO3 will readily accept that proton and it will form the H2O plus and NO2 and it will form the HSO4 minus conjugate base. This is the conjugate base. This is brown state base, conjugate base. Now this is brown state base, conjugate acid. This is conjugate acid. Clear? Now this conjugate acid oxygen, it is having the positive charge because this oxygen lone pair has accepted this proton. Now oxygen mele positive ideyalva. Now to stabilize this positive charge, now this bond pair of electron has been shifted toward this oxygen. When this bond pair of electron has been shifted toward this oxygen and we are getting the one electrophile, that is a nitronium ion. By this we have generated the electrophile. Now this electrophile should be attached to the benzene alva. Now this electrophile should be attached to the benzene. Clear? Now this conjugate base, this you remember, this conjugate base. Clear? Now ಈಗ ಬೆಂಜಿನ್ ಮೇಲೆ when you shift this pi bond, ಈಗ ಇದರಲ್ಲಿ ಏನ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ವಾ. now negative charge, now this nitronium ion will be attached to this positive charge. now when this pi bond has been shifted toward this carbon, ಈಗ ಈ ಕಾರ್ಬನ್ ಗೆ ಏನ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಈಗ this to stabilize this positive charge, now this bond will be delocalized. Again this pi bond will be delocalized. ಇದರಲ್ಲಿ you will get the positive charge. ಇದರಲ್ಲಿ ಸಿಗ್ಮಾ ಕಾಂಪ್ಲೆಕ್ಸ್, ಇದೆಲ್ಲಾನು ಸಿಗ್ಮಾ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ವಾ. this is the intermediate. now the elimination of the H plus alva, elimination of the H plus. after this again this sigma bond will be delocalized and the aromaticity will be stored and we get the nitrobenzene. By this we got the nitrobenzene. Clear? Now when this hydrogen has given this sigma bond, now it has been eliminated with the positive charge alva. It has been eliminated with this positive charge. Clear? When it has been eliminated with the positive charge, ಇದರಲ್ಲಿ conjugate base ಇದೆಯಲ್ವಾ, now starting ಅಲ್ಲಿ I said you right, when we have generated the electrophile and the nucleophile, first we have to generate the electrophile and the nucleophile will be there, right? now ಇದರಲ್ಲಿ we have generated the electrophile and this is the nucleophile. HSO4 minus is the nucleophile. now this nucleophile whatever the hydrogen is eliminating, that it will be attacked to this nucleophile alva. now see, whatever the proton it has been eliminated, we are having HSO4 minus is a conjugate base alva. now whatever the proton we have eliminated, that it will be attacked and it will get the H2SO4. again we'll get the H2SO4 and by that we are getting this nitrobenzene. Clear? whatever it may be. Clear? now ಈಗ ನೋಡಿ, if now concentrated HNO3 and concentrated H2SO4 ಈಗ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ನಾವು ಒಂದೇ ನೆನಪಿಟ್ಕೋಬೇಕು. now this will increase the electron density at which position? ortho and the para positions alva. now the electrophiles we generated is a NO2 plus nitronium ion. now this nitronium ion is a bulky. now here we are having the two chance. either it can be attacked at the ortho position, either it can be attacked at the para position. Clear? next ಈಗ ಫಿನಾಲ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ನಾವು ಫಿನಾಲ್ Now phenol also will increase the electron density at the ortho and para positions alwa. Idralli minus charge barutte, idralli minus charge. Now the electrophile we get it as a positive. Now here also we'll get the phenol, orthonitrophenol and the paranitrophenol, and we'll get the orthonitrophenol and the paranitrophenol. Here also we'll get the two types of the compounds. Clear? Now here benzene attached groups will decide where to attack the electrophile. Benzene attached groups will decide the where to attack the electrophile. Clear? Next. Next, halogenation. ಈಗ halogenation reaction ಅಲ್ಲಿ this anhydrous first we have to generate the electrophile alwa. Now Cl. Now this is a Cl. Okay. Now this is anhydrous AlCl3. Anhydrous AlCl3. This is a Lewis acid. This is a Lewis acid. Lewis acid andre eno, the one which accept the electrons are known as the Lewis acid. Now aluminum AlCl3 is a Lewis acid. Now how it is acting as a Lewis acid andre, aluminum, now 1s2, 2s2, 2p6, 3s2, 3p1 alva, 3p1. Now due to the presence of empty p orbital as well as the empty d orbital, due to the presence of empty p orbital and due to the presence of empty d orbital, aluminum will accept the electrons, one which accept the electrons is known as the Lewis acids. One which readily accept the electrons are known as the Lewis acids alva. Now due to the presence of this empty orbital, now this chlorine electrons will be accepted by this Lewis acid. When it is accepted, now chlorine, now this it will get the AlCl3 minus. Now this chlorine will get the positive charge alva. Now to stabilize this positive charge, now this bond pair of electron has been shifted toward this chlorine and will get the L4. Now this will get the AlCl4 minus. Idralli we have generated the chlorine as the electrophile. Chlorine electrophile has been generated. Idralli chlorine electrophile has been generated. Now this chlorine electrophile, now it will be hydrogen. Now this bond will be shifted here. When this bond has been shifted, now this electrophile will go and attack. Now idralli negative charge baruttalva. Oh sorry, electrophile yavadu? Cl positive. Idralli get Cl. Idralli will get the positive charge. Again this will be delocalized. Idralli positive charge. Again it will be delocalized. Idralli positive charge. Clear? Now this is the alpha complex alva. Now next, elimination of the chlorine alva. Sorry, elimination of the hydrogen. Now this will be delocalized. Now we'll get the aromaticity restored again. Now we'll get the chlorobenzene. Now we'll note a question. ಈಗ NO2 ಕೊಟ್ಟಿದ್ರಂದ್ರೆ Cl2 or else if okay CH3 and OH. Now way to attack Cl2 in the presence of anhydrous AlCl3. Anhydrous AlCl3 ಅಲ್ಲಿ Cl chlorine is a electrophile alva. Now it will decide, this will decide the where to attack the electrophile. It will attack at the 1 here and one it will be attacked at the position. Clear? Now next Cl2. one will be attacked at here and one will be attacked at para position, because this will increase the electron density at the ortho and para positions alwa. Okay, next next one, that is sulfonation. Sulfonation alli this is very very important. Sulfonation alli here the concentrated H2SO4, here the concentrated 2 moles of the concentrated H2SO4 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ H2SO4 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ here we are getting the neutral electrophile as the SO3, neutral electrophile as the SO3. now ಇಲ್ಲಿ ನೋಡೋಣ. first this is the structure of H2SO4, this is the structure of H2SO4. now ಈಗ H2SO4 ಹೆಂಗ್ ಬರಿಬಹುದು ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, how to draw the H2SO4 structure ಅಂದ್ರೆ sulfur valency electrons ಎಷ್ಟು, sulfur valency electrons ಎಷ್ಟು, oxy acids of the sulfur can form, oxy acids of the sulfur can form one double bond O, one OH. this is a oxy acid of the sulfur. now sulfur valency is 6 alva, already it has formed the 3 bonds. now remaining left is 3. now hydrogen never will be directly attached to the sulfur, that you have to remember. hydrogen never will be attached to the sulfur. now H2SO4 ಅಲ್ಲಿ 2 oxygen 1 hydrogen has been balanced, 2 oxygen 1 hydrogen has been balanced. ಇನ್ನು 2 oxygen 1 hydrogen we have to balance alva. so oxygen can form the double bond. now 1 oxygen can form the double bond. now ಇನ್ನೊಂದು oxygen, now hydrogen. clear? ಇನ್ನೊಂದು oxygen 1 hydrogen. now this is the structure of the H2SO4, this is the structure of the H2SO4. clear? now next ಇಲ್ಲಿ ನೋಡಿ, here this H2SO4, this H2SO4 one readily will give the H plus alva, one readily will give H plus alva. due to the presence of this lone pair of electrons, oxygen will directly abstract this acidic hydrogen. when this abstracted this acidic hydrogen, now idralli will get the H2O and will get the conjugate acid alva, one conjugate acid, sorry conjugate base alva, O minus. now here this oxygen bearing the positive charge is unstable. now what it will do, it will give the bond pair of electron to stabilize this positive charge. now after the stabilizing, now here we are having, this is eliminated as the H2O, this it has been eliminated as the H2O alva. now here we are having, when this bond pair of electron has been given to this oxygen, now this sulfur will get the positive. now here the sulfur will get the positive, one double bond O, one double bond O, one OH, one double bond O, one double bond O, one OH. now this bond has been taken by this OH alva, so sulfur is getting the positive charge. clear? now if this positive charge, if sulfur is having the positive alva, now by giving this sigma bond pair of electron to this sulfur, now here this SO3, this is SO3. now this is SO3 is a neutral electrophile. ಯಾಕಂದ್ರೆ this sulfur is attached with the 3 more electronegative groups alva. this sulfur is attached to with the 3 more electronegative groups. when this attached with the 3 more electronegative group, now this sulfur is having, idral nodi, this bond pair of electrons was pulling by this oxygen, this bond pair of electrons was pulling by this oxygen, this bond pair of electrons was pulling by this oxygen, andre it is having more positive charge. this sulfur central atom sulfur, it is having more positive charge. ಈಗ ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ it will act as a electrophile alva, it is act as a electrophile alva. ಅದಕ್ಕೋಸ್ಕರನೇ it is acting as a neutral electrophile. ಅದಕ್ಕೋಸ್ಕರನೇ why, due to the presence of these 3 more electronegative groups attached to the central sulfur, due to the presence of the more electronegative group, it is having the more positive character, more positive character. ಅದಕ್ಕೋಸ್ಕರನೇ we call it as a neutral electrophile. ಯಾಕಂದ್ರೆ without having charges we calling it as a neutral electrophile. this SO3 is a neutral electrophile. with the SO3 is called as a neutral electrophile. now this neutral electrophile should be attacked to the benzene alva. clear? now this neutral electrophile will be attacked to the benzene. now this neutral electrophile will attack to the benzene ಹೆಂಗಂದ್ರೆ ನೋಡಿ, this is double bond O, now this is double bond O, now this is double bond O alva. now this pi bond has been shifted here, now this will get the negative charge. now this pi bond will be shifted toward this oxygen. when this pi bond has been shifted toward this oxygen, now this sulfur will get the positive charge alva, this positive charge alva. now Now this positive charge sulfur will go and attack here. Now this positive charge sulfur will go and attack here and will get the this structure. Okay. Yes, sir. Double bond O, O minus, O minus. Clear? Now here that is the alpha complex. Now elimination of the what? Elimination of the hydrogen. Elimination of the hydrogen, it should be take place, alva. Now this sigma bond will be given to the ring and the aromaticity stored, and we are getting the SO3 minus. Now idra solutionally we are having the plenty of water molecule, alva. Adralli this will give the H plus. That H plus will go and attack here and will get the benzene sulfonic acid. It will get the benzene sulfonic acid. ಈಗ benzene sulfonic acid ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ benzene sulfonic acid. By that ಈಗ concentrated H2SO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ on the benzene will get the benzene sulfonic acid. Here the neutral SO3 in sulfonic acid. ಈಗ statement based question ಅಲ್ಲಿ ಅವ್ರು ಹೇಳ್ತಾರೆ ಏನಂತ ಹೇಳ್ತಾ ಇದ್ರು ಅಂದ್ರೆ in aromatic electrophilic substitution reaction ಅಲ್ಲಿ sulfonation what is the electrophile SO3 neutral SO3 is the electrophile that is generated in the sulfonation. Clear? Next, Friedel-Crafts alkylation. ಈಗ Friedel-Crafts alkylation is very important. ನೋಡಿ ಈಗ Friedel-Crafts alkylation ಅಲ್ಲಿ now AlCl3 is a Lewis acid, alva. Now just now I explained you how the AlCl3 is acting as a Lewis acid anta. Now CH3Cl, this is methyl chloride. Now this is AlCl3, anhydrous AlCl3. Now due to the presence of empty p orbital or empty d orbital, it will act as a accept the lone pair of electrons. When it is accepted the lone pair of electrons CH3, now this chlorine will get the positive charge. Now this will having the AlCl3. Now this chlorine, it is having the positive charge, alva. To stabilize this one, now this bond pair of electron has been shifted toward this chlorine and will get the methyl cation as the electrophile and will get the AlCl4 minus. Now this is the electrophile we have generated, alva. Now this electrophile should be attached to the benzene. Now this electrophile should be attached to this benzene. Now when this electrophile has been attached to this benzene, now what we'll get? We'll get the toluene. This is the toluene. Clear? Now Friedel-Crafts alkylation ali alkyl is the electrophile. Clear? Now next, this reaction is very important. Friedel-Crafts alkylation ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ when they have given the propyl chloride ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ what you have to do means, now same thing, now AlCl3 now ಇದರಲ್ಲಿ empty p orbital ಇರುತ್ತೆ. Now this will accept the electron. Now here the Cl will get the positive. Now it will get the AlCl3 minus. Now to stabilize this one, we have to give the bond pair of electron. Now here we are getting the positive. But ಈಗ ಈ ತರ ಕ್ವೆಶ್ಚನ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ options, it will be this also. This option also will be present in that solution. Okay. Now this option will be present in the option, but this option it is wrong. ಯಾಕಂದ್ರೆ this is wrong. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, this carbocation is the primary carbocation, alva. This is 1 degree carbocation. Can we make this stable carbocation? Yes, by shifting the 1,2 hydrate shift. ಈಗ ನಾನು 1,2 hydrate shift ಮಾಡಿದನಂದ್ರೆ ಏನಾಗುತ್ತೆ? I will get the secondary carbocation. Now this is a secondary carbocation, alva. Now this is a secondary carbocation. Now secondary carbocation is more stable than the primary carbocation. Now this is our electrophile. Secondary carbocation is our electrophile. Secondary carbocation is our electrophile, not the primary carbocation. ಈಗ ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ you have to be very careful. You have to be very careful. Clear? Now, not the primary carbocation, secondary carbocation. ಇದರಲ್ಲಿ rearrangement ಆಗುತ್ತೆ. ಇದರಲ್ಲಿ rearrangement ಆಗುತ್ತೆ. Rearrangement, by that rearrangement only, we have to attack it to the benzene. Clear? Now, here, now that it will be attacked to the benzene. Now, this is the electrophile. Now, it will attack it to the benzene and will get the isopropyl benzene. And it will get the isopropyl benzene. Now, this is a isopropyl benzene. Clear? Now, ಇದರಲ್ಲಿ propyl chloride ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ first we have to make the stable carbocation, then we have to attack to the benzene. ಇದರಲ್ಲಿ we have to make the stable carbocation. Next, if ಈ ತರ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ benzene in the presence of Cl, or in the presence of anhydrous AlCl3 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ now what is the answer for this one? See, ಈಗ this is anhydrous AlCl3. ಇದರಲ್ಲಿ lone pair, now this will lone pair ಇರುತ್ತಲ್ವಾ, now this will be attacked to this benzene. It will be attacked to this AlCl3 Lewis acid. Now this Cl will get the positive charge. Now ಇದರಲ್ಲಿ AlCl3. Now ಈಗ this chlorine, it is having the positive charge alva. By that will generate this electrophile. Clear? Now ಈಗ this electrophile, it is a primary carbocation alva. Now this electrophile we have generated here, alkali we have generated here, this is primary carbocation. More we can make the stable carbocation by shifting this hydride 1,2 hydride shift ಮಾಡಿದಾಗ. ನಾವು ಈಗ how you are shifting this 1,2 hydride shift ಅಂತ ಈಗ ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ you can see the alkene chapter lecture number 2. ಆ lecture number 2 ಅಲ್ಲಿ ನಾನು ಕ್ಲಿಯರ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ಕ್ಲಿಯರ್? ಈಗ ನಾವು lecture number 2 ನೋಡಿದೀವಿ ಅಂದ್ರೆ that there you will get to understand very clearly. Okay, now ಈಗ by shifting this 1,2 hydride shift, now here we'll get the positive charge. Clear? Now still we can make the stable carbocation. This is 2 degree carbocation alva. This is 2 degree carbocation. Still we can make the stable carbocation by shifting this hydrogen to here. Now by shifting this hydrogen to here, I can make the more stable carbocation. Now this is 3 degrees more stable carbocation. Now this is the more stable carbocation alva. Now by rearranging, we have arranged this to the more stable carbocation. Now this electrophile will be attacked. Now this electrophile will be attacked to the benzene. When it is attacked to the benzene, now we will get the, now 1, 2, 3. Now this is the compound. Now this is the compound we are getting. Clear? When the Friedel-Crafts alkylation reactions ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, when the Friedel-Crafts alkylation reaction ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, you have to be very careful. This alkali halides, now you have to see the carbocation stability order. By seeing the carbocation stability order, ಇಂದನೆ you have to attack to the where on the benzene. Same process, electrophile generated, sigma complex directly I have attacked. See clearly, again and again I am not following the steps. First, second, third ಎಲ್ಲಾನು ನೋಡಿದೀವಲ್ವಾ, so directly I was attacking here. Okay, next. Next, Friedel-Crafts acylation. ಈಗ Friedel-Crafts acylation ಅಲ್ಲಿ same, this is having the Lewis acid, it will take the bond pair of electron and we have generated the electrophile, that is a acylium ion. Acylium ion is a stable electrophile. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, this carbocation is stabilizing by the resonance. Oxygen ಮೇಲೆ lone pair ಇದೆಯಲ್ವಾ, this is stabilizing by the resonance. When they ask which electrophile is more stable among the alkylation and the acylation, which electrophile is more major andre acylation electrophile is more major, because this electrophile is stabilizing by the delocalization. delocalization this electrophile is generating. Now this electrophile will be attacked to the benzene. Directly I am attacking. Now here this will be directly, it will go and attack. Now we will get the now this is the product we are getting. This is the product we are getting. Okay. Now next ಈಗ ಎಸಿಡಿಕ್ ಅನಹೈಡ್ರೈಡ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ, ಈಗ ಎಸಿಡಿಕ್ ಅನಹೈಡ್ರೈಡ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ನಾವು ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾಪನ್ ಅಂದ್ರೆ, ನಾವು ದಿಸ್ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಬಿ ಗಿವೆನ್ ಟು ದಿಸ್ lone pair of electrons has been given to this acid. Now when this lone pair of electrons has been given to this acid, now ಏನಾಗುತ್ತೆ R C double bond O, oxygen ಮೇಲೆ positive, now AlCl3 is, now here C double bond O, now R. Clear? Now oxygen ಮೇಲೆ positive charge, it is unstable, it will give the bond pair of electron towards itself and we are getting the helium ion. Again the helium ion as a carbo or helium ion as a electrophile. Now helium ion is the electrophile. Now this helium ion has been attacked to the benzene. Now again we will get the same. Clear? Now ಈಗ if ಈಗ ಈ ತರ ಕ್ವಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಬೆಂಜಿನ್ and the acid chloride, clear, in the presence of anhydrous AlCl3, anhydrous AlCl3 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಅದು ಕ್ಲೋರಿನ್ ಮೇಲೆ ಲೋನ್ ಪೇರ್ ಇರುತ್ತಲ್ವಾ, sorry, this is X, this is X, not chlorine, this is X, this is X, sorry. ಈಗ ಕ್ಲೋರಿನ್ ಮೇಲೆ ಒಂದು ಲೋನ್ ಪೇರ್ ಇದೆಯಲ್ವಾ, now it will be given to this. Now here we will get the CH3, C double bond, Cl, now chlorine ಮೇಲೆ positive, now AlCl3 negative. Now chlorine ಮೇಲೆ positive is unstable, now it will be taken by the electrons. Now here we will get the CH3, C double bond O positive. Now this positive will go and attack to the benzene. Now electrophile has been generated, we will get the acetophenone. Now we will getting the acetophenone. Now we are getting the acetophenone. Clear? Now by ಈಗ ನೋಡಿದೀವಲ್ವಾ ಎಲ್ಲಾನು. By this we have ended our important lecture. ಅದು ಯಾವುದು ಇಂಪಾರ್ಟೆಂಟ್ ಲೆಕ್ಚರ್ ಯಾವುದದು? ಅರೋಮ್ಯಾಟಿಕ್ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್, ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ನೋಡಿದೀವಲ್ವಾ. ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅಲ್ಲಿ ಹೌ ಟು ಪ್ರಿಪೇರ್ ದ ಬೆನ್ಸಿನ್ ನೋಡಿದ್ವಿ, ಆಮೇಲೆ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ, ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಎಲ್ಲ ನೋಡಿದೀವಲ್ವಾ. ಅರೋಮ್ಯಾಟಿಕ್ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅದರಲ್ಲಿ ನಿಮಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್ಸ್, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಂಗ್ ಆಕ್ಟಿವೇಟಿಂಗ್ ಗ್ರೂಪ್ಸ್, ಸ್ಟ್ರಾಂಗ್ ರಿಂಗ್ ಡಿಆಕ್ಟಿವೇಟಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಎಲ್ಲ ನೋಡಿದ್ವಿ. ನಾವು ಬೆನ್ಸಿನ್ ಮೇಲೆ ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸ್ಡ್ ಆ್ಯಂಡ್ ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಕ್ರೀಸ್ ಅಂತ ನೋಡಿದ್ದೀವಲ್ವಾ. ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ ಅಂದರೆ ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ, ನಾನು ಕ್ಲಿಯರ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಸಿ ಯು.